Determining the domain and range of a function. I think it's always helpful to graph it or draw it out, but if there's no restrictions, your domain's going to be all real numbers. Here's a symbol for all real numbers, or you can write all real numbers. So I'm going to graph this one out. Y equals x squared is a quadratic and it looks like a parabola. Well, domain, if I'm trying to find the furthest to the left to the furthest to the right, there is no pinpoint where I can start furthest to the left. It keeps going, going, and going, and same thing on the right. That's why it's all real numbers. Whereas the range does have a bottom. And the bottom of this graph is 0, but it goes up and up and up forever, so it goes from 0 to infinity. Or you can say y is greater than or equal to 0. Let's look at another problem. I need to find the domain and the range of this. Well, the domain, when it comes to a square roots always have to be positive. So whatever's in the square root, for example, 2x plus 4, it has to be greater than or equal to 0. Because if it's less than 0, it becomes negative. So let's go ahead and solve. 2x is greater than or equal to 4. Divide by 2, so x is greater than or equal to 2. So one way we can write the domain would be like this. The other way we can write the domain, well, I can graph it out. At 2, it would have a little dot right here, and it goes something like that. Use your graphing calculator to help. So the furthest to the left of this graph right here would be right here. So it would go from, so another way to write this is from 2 to infinity because it doesn't stop. Interval notation, inequality notation. Range starts from the bottom. So the range is your y values, and what's the bottom y value? Well, that's 0. Well, the graph is everything above it. So you can write it in inequality notation, or you can say it's from 0 to infinity. One last problem here. So we're going to look at a rational problem. Now, what do we know about this? We know that in the domain and range, we know that the domain, this part right here, cannot be 0. So I know that the bottom cannot equal 0. So if I take x minus 2 and set it not equal to 0, x cannot be the number 2. So at 2, we would have an invisible line right here, and that's called an asymptote. So the domain can be all real numbers except two. You could write it from negative infinity to 2, but open, and then again from 2 to infinity, so I'd accept either one of those. Now, you're going to have to use your graphing calculator to graph this. We'll get more into rational functions later, but it looks something like this, and then something like this. So y is never going to equal 0 as well, because you can see right here that it doesn't touch it. So we can say from negative infinity to 0, then again from 0 to infinity, or all real numbers except y cannot equal 0. So we'll get into more of these functions and why they happen later, but what you need to know for the domain is that the bottom can never equal 0. So if I plug in a 2 right there, that would make it undefined.